Hello again, everyone. Today's discussion is going to build off our prior discussion by focusing in on the topic of multivariate regression. So in the past, we've talked about bivariate regression, where we've looked at the relationship between one independent and one dependent variable. And now we're talking about multivariate regression, where we have one dependent variable and two or more independent variables. Now, I've got a data file up right now, which is let me flip over the variable view to make it easier to see. This is state-level UCR data. You can see we've got a series of offenses, the counts. And what I've done is I've gone a step further here, and I've actually created 3 variables of crime counts in terms of the violent property and index crime. From there, I've also created 3 crime rates, taking into account the population and measuring this out by 100,000, so we can talk about crimes per 100,000. I also have an unemployment rate variable. I have an unemployment categories variable, which is just simply a dichotomous measure of the states that had unemployment rates below the median versus states that had unemployment rates above the median, and median in this case being the median unemployment rate, states that are in the southern region, and then finally the median household income. Now, the relationship between running a bivariate and multivariate regression are almost the same. The same process, the same command. It just means in terms of interpretation, we need to be aware of what we're doing. So let's go right into it. I'm going to go to Analyze, Regression, Linear. And this time, I'm going to say that my outcome variable or my dependent variable is going to be the violent crime rate. And I'm going to say my median household income is my independent variable. Now, on top of that, I'm simply going to add my dichotomous unemployment rate. Now, I've made sure not to include both my continuous unemployment as well as my dichotomous unemployment, because I'm sure I would run into multicollinearity issues if I did that. So instead, I'm going to leave them separate and simply say OK. Now, if you take a look at this, you're going to see that we have what is not considered to be a particularly helpful model. And that may be a little bit of an understatement here. Notice that we have up at the top, it tells me my dependent variable is violent crime. My independent variables included in the Mahler median household income, as well as that dichotomous measure of unemployment. My R squared, which tells me the proportion of the variation of the dependent variable, which is explained by my independent variables, is low. We would say this is multiplying out by 100 to make a percent. We'd say it's less than 2%. And we can see right away that my ANOVA model, which tells me whether or not this model fits better or explains a significantly more variation in the dependent variable than simply using the mean of the dependent variable, it's non-significant, which actually suggests I shouldn't even read this last part down here in terms of the coefficients, because there's nothing worth talking about here. And so I thought this was a pretty good place for us to start. So let's think about this a little bit more and figure out what we can do to come up with a better regression model, or a regression model that maybe actually explains some of the variation in my dependent variable. So I'm going to go to Regression, Linear again, and I'm going to take out both these measures, and instead I'm going to say my violent crime rate is my outcome. Let's see what happens when I put property crime in as my independent variable. And I say OK. And I know this is a bivariate relation. Let's start there. Now we have a little bit more success. You can see that we have an R squared of about 0.24, suggesting that we've explained about 24% of the variation in my outcome measure using simply the property crime to explain violent crime. The ANOVA is significant, suggesting this model has explained significantly more variation than just simply relying on the mean of the dependent variable. And more importantly, coming down here to the coefficients, you can see we have a significant coefficient for my property crime rate, suggesting as my property crime rate goes up 1 unit, we see a corresponding increase in the violent crime by about 0.24, so about a 1 to 4 relationship in regards to the crime rate to the crime rate. So if my property crime rate increases ultimately fourfold, we'd see a one-time increase or a one-fold increase in the violent crime. And by the way, that's not uncommon. In fact, that makes a lot of sense, because we would always anticipate that we are going to have a great number more property crimes than we are violent crimes. Or at least I think we can all agree we would hope that's always going to be the case. Okay, so this is a bivariate regression. actually doesn't tell us too much more than the correlation does, except perhaps the precise nature of that relationship. Let's add another variable in. So I'm going to go to regression again, and I'm going to go to linear, and I'm going to go back down to those other measures, and I'm going to put that unemployment categories back in now, and let's see what happens. So you can see that controlling for unemployment categories, the model's increased a little bit, from about 0.24 to about 0.28 in regards to the R squared. The model's still significant, but you can see right away that unemployment categories variable itself is not significant. So we would say it's not a significant predictor of my dependent variable of the violent crime. Now, on the other hand, the coefficient is sort of interesting, which is, if you think about it as the lower values, the lower value in this measure corresponded to lower unemployment, and higher values indicated higher unemployment rates, then you would see that the higher unemployment rate is actually, on the average, associated with about 26 more violent crimes. And again, when I say violent crimes, I'm saying violent crime rates, so 26 more per 100,000 of the population. Again, it's non-significant, so we can't look too much more into it, but certainly is going in the direction that we would have hypothesized. I'm going to go to regression again. And this time, I'm going to take out the unemployment categories, and I'm actually going to put in a measure of states in the southern region. You know, I don't want to get into too theoretical here, but there's always been some questions or concerns or hypotheses around the idea of whether or not there's sort of a subculture of violence in different regions of the country. So this was an example that was raised by a student. And so we identified, according to the federal government, what the southern states are, the states that fall in the southern region. Now, that may not relate directly to that idea of the southern culture of violence, but let's simply say okay here. And you can see that once again, while property crime is a significant predictor and the coefficient there has changed very little, you can see the R squared has changed very little as well. The states in the southern region is still non-significant. Now, while I don't want to turn this into a fishing expedition to find variables that are statistically significant, I do want to try and find one to allow us to sort of talk about the interpretation here a little bit easier so that we can go through a couple of different examples. So let's do one more and then we'll stop. I'm going to go to Analyze, Regression Linear again. And this time I'm going to take out the violent crime and let's put property crime in. Now if I do that, by the way, see, it gave me an error. It didn't like the fact that I had property and independent dependent. So let's pop that out and then pop that back up in there. I'm going to leave the states in the southern region. And then I'm going to put the unemployment rate in. And let's see what we have here. Now in this case, I'm just going to jump right to the chase. We've got a non-significant ANOVA. We do not have a statistically significant relationship between these variables. So again, this model kind of went bust. I'm going to go to Analyze, Regression Linear again. Let's put in maybe the median household income. And I'm going to put in as well the unemployment categories. Now, here you can see that even when I've included these, and of course part of what we're talking about here is a real concern about the level of analysis and the amount of variation we're talking about, you can see here that we're not actually coming up with much that's significant, which means that ultimately we can't really take much time to interpret these coefficients. Now, in some ways that's good. This unemployment variable is actually now going not necessarily in the direction that we would have anticipated with a crime variable, but it's a non-significant relationship, so we're not really going to draw too much from that. So let's just do one last one. And this time, what I'm simply going to do is I'm going to cheat a little bit, and I'm going to put the violent crime rate back in. And let's put in maybe the states in the southern region and see what happens. And if it's not significant, then we're still going to interpret it just for ease. And sure enough, you can see states in the southern region is not a significant variable. You can see that in the bottom of the sig of 0.396. Now, my R squared is about 0.25, suggesting that about 25% of the variation in property crime is explained by violent crime and that dummy variable of states in the southern region. The ANOVA tells us it's a marked improvement over simply relying on the mean as the best estimate of the dependent variable. You can see in this case that we have a much higher rate associated with the violent crime rate. A 1 unit increase in the violent crime rate corresponds to about 0.970 increase in the property crime rate. And then finally, states in the southern region, well, it's non-significant. I am going to say if it was significant, and yes, caveat here, I know it's non-significant. We can see it's non-significant because it's got 0.396. But if it were significant, then I would say, because this was coded as 0 are non-southern states and 1 are southern states, I would interpret this to say that on the average, the southern states have about 48.5 more property crimes as compared to the non-southern states. All right, so this is a bunch of examples, and hopefully you saw that sometimes our models don't work the way we anticipate. And one of the things is that, of course, as we add more variables, our models become more complex. And you'll find, particularly with small sample size like we have in this example, it actually can be quite challenging to find statistically significant relationships, particularly when you don't have something that's maybe as precise as you want it to be. All right, as always, if you have any questions, you are more than welcome to contact me. And of course, have a great day. Thank you.